In this video, I'm going over the assembly and how to create the assembly and apply some mate, that is relation between the parts and surfaces together. And then at the end, I show you a video about the more advanced feature inside the assembly apps. To run the assembly and assembly app, just go to your compass, and from the apps you can search for the assembly, and then if you can find the assembly design, you just click on the assembly design and the software run the app in your computer. You need to notice that so you may get some notification about the graphic card that the system is not compatible with the graphic card, but it doesn't matter, and still software will run in your computer. So just click OK and wait for the app to run in your computer. You need to notice that these apps, part design and also assembly design, drawing, they are running through the project of the year platform, and whatever that you do and save, it will save in the directory of your project of the year. So here I have two different access for the different platforms, and on the always on I have the X design. So if I go back here, so I have X design in my always on platform. So if I run this app and save any files, it will save in my always on app. So here in my that category in the folder, and any files or any item that I create in the part design or assembly design, it will save in the project of the year. So I have all of these items in my project of the year. These are in my 3D space, and also you can open different drive in your computer or in the 3D drive, and these are the files that you can save, and there's a different category that you can have access to that. So I have 3 again, and right now I'm working on the project of the year because this app run through the project of the year. So I received some notification, an error, because I had the different license before, and right now the software running and those licenses not activated anymore, so it gave me some error. So I just close this. Then okay, so this is the environment for the CATIA on the assembly design, as you can see in the top, and it's run through my hardware. So it is installed in my laptop, in my hard drive, and I can access to this software through my dashboard. So when I click on the dashboard and the assembly design, it's run through my hardware and open these pages. You have different options to start and adding the file for the to create your assembly. So you can recall the part from the from this part from the production modification, and you have create a new product, or you can, if you have already the parts that you designed before, you can insert them from here, or you can right click on the name of the project, and then from here you go down, and from the insert you select the existing product or the new product if that you have. So There's a different way that you can recall the parts into your assembly project. So you can search them and then you can add multiple parts, or you can put them one by one, or you can open each file individually through so you can open the physical product and then you call them from here. So if I go back and open some of the files that I have, and then I can open them, and then I can show you how you can add them to your assembly. So I go to the 3D part. So I selected the add, and I selected the new new part, and as you can see here, it creates a new part if you want to design a new part. If you have already something in your computer, you can just recall the 3D part and from your hard drive. So I can just so let me open some of the files that I have in my computer. I select the import, and I select from my hard drive, or I can select from my 3D space, my collaborative space, that it will recall the files that I have here in my so it's called recall from the project of the year and any files that I have here. So I can select collaborative space, then I can open the file. So here you can see that it gives me the notification that I need to search through my drive. So I click here and I go to all of my content. So I click on the search and I go to all of my content, and it shows all of the parts that I have in my parts. So there's some problem with the connection to the internet, so I just use from my hard drive, and I click the file that I want to open. So this is the first one. I click this one. So here first I open all of the files that I have, the part design that I designed, and then I go back and the assembly design and I add them inside my assembly. Okay, so you can see that it opened the part design that I created here. Then I import the two other parts too. And I open the last part. Okay, so now I open all of my files. I go back in my assembly design and I request to put the existing product in my file. So here you can see that it gives me options that either I go and select from I can either go to my content and find the data that I have in my 3D space, or I can just go and click on the files here and I select on the names, and you can see here it says that I selected the multi selection. So I can select the more files here, or I can add them one by one inside my assembly design. So here I select I click on the multiple selection, and I select on the files that I want. So I select on the names, and then it shows here I have two objects, and I can expand this to see the object that I added, I selected. So I select the last part too, and then I click OK here. Now it put all of the files that I called inside the my assembly environment. Then I want to first move them apart, and then I put them in the rotation and the direction that I want to have, and then I start to defining the relation between the this part. So the goal of the creating the mate is to reduce the degree of the freedom. And when I'm talking about the degree of the freedom, it means that the movement of the part, we want to reduce the movement of the parts and in relation together, and reduce the amount of the degree of the freedom. So usually if you look at this robot, we have three main degree of the freedom in the direction of the three main coordinate system, and then we have 3 rotation. So in total we have 6 degree of the freedom, and then we with assigning the different mate, we reduce this degree of the freedom and fix them in the assembly. To create a different degree of the freedom or movement or the mate, you go to the assembly, and then you have a different options for the defining the part and the mate. So the first one is creating the mate, and then if you want to define the joint between the two parts, you can create a use the interface based connection. That it means that if you have points like the ball points, or you have a different type of the movement, you can define two parts together. And also you can create the free movement for the parts, and just move them freely in the space without any kind of the relation between the other parts. The next couple of the items is for creating the more and adjusting the part inside your assembly. For example, you can duplicate your item here. So let's say that if I have more than the one plate, I can duplicate that here and make the symmetry in accordance with the one of the main plate or any faces. So I can duplicate the object, or I can create some kind of the pattern. For example, if you have one screw here, you can use the pattern and fill out all of the holes here. So you just recall one part, and then you pattern them through the object that you have. And also you can create the hole. And if you need another hole here, instead of going back inside your part design and put the hole, you can use it here. And the difference from these options here is that you can create the hole if you in your assembly, and this hole can pass through the different parts. So for example, if I create the hole here, this hole can pass through this plate too. So if you have one assembly joint, you can easily create the hole that go through all of the different parts. Okay, so now let me just move start to moving the part. And when you click on the manipulation or movement of the part, you have different options. So the first row is for the moving alongside the one axis, and then you have the movement through the one plane. So you have a different options for the plane, and the last one is the rotation through the different axes. So for the last column, you can define the line of the axis that you want to move. So instead of going to X, Y, Z, you can select any any lines that you have. So as you can see, when I move my mouse, it's selected there. It show you the different line, and then if I click on that, I move the part alongside that. So if I click on this one, that is, and then I can click on the move on the mouse and move the part alongside of that line. So I select on the X, and you can see the direction here. So I select the X because I just want to move them apart and then start working on them. And then I rotate the part through the, so I just start rotating this part, and this is the part. I just leave it there. I just, okay, then I click on this one and I just move it alongside the X. So then I move it to the Z. So I just the way I want to assemble this part is that I put this bar inside this hole, and then I define the distance between the back of this bar and the back of this plate or my base as a like a 25 millimeter, or I can define it as a some kind of the bracket and move it between the 10 to 15 or 50 millimeters, so the back can move from the two position. So that's a different type of the mate. And then I place this plate at the back of this rod, and at the end I parallel all of this plane to this face, so this plane and this plane. So let me move my let me move this plane to plate. So I just want to okay. Let's see, I just go up. Okay, so this is a, let me get back a little. Okay. So this is all of the parts that I have. As you can see, they are not at the same level, and I start to defining the relation between these parts. So I start with this one, and then add the this plate to the back, and then I start to defining the sides. So the first one, you have two different way to define the relation and also the mates. So for the start, I want to make this part fixed. So I just want to make sure that one of the items that I have in my assembly is fixed. So all of the other parts define the relation with the main one. So I select this one, I select the fix, and I select the I think the name is the plate. So I click on that. Now I fixed my my plate or my guide as a fixed option, and you can see that in my tree I have extra item that is the engineering connection, and the fixed one, when I go there, you can see that it's highlight my base. Now I select the outside of my bar, and then I keep the control down, and I select the inside part of my hole, and then I click at the add, and I click the engineering connection. So here the software automatically define the relation as a coincident. So that's something that the software automatically define for you. And I click OK here. So the software tell you that there's no clash between the parts. So that's a good sign. because you don't want to have any kind of a clash. So now I move the parts again, and this time because I want to have access to the back of this rod, so I just want to move it a little outside so I can select the back very easily. And in this part, in this time, I select the tick for the with respect to constraint. So I don't want to move my part freely in the space because I defined one relation. I just want to movement be in accordance with my relation. So if I click this one, I can only move this bar through this hole. But if I untick this bar in this item, then I can move the bar anyway outside or inside the parts. So I just want to keep my relation in the part, and then I click the through the axis, and I define the axis as the center of my hole and my bar. So I select the free drag, and then I define the axis as the direction of the movement, and I click OK. Okay, now I move my part, and now I want to put this plate in the contact with my bar here. So the first thing is that I will select I put the center of this hole with this hole here as a concentric, and then I put the back of my bar to the front face of this plate in contact, and then I start to parallel the faces here, these three faces. Okay, so I select the inside of this, so to show you better, I select, if I move the mouse, I select the inside of this hole, then I keep the control down, I select the inside of the next hole, then I select engineering connection, and I make it concentric, so it didn't select the to move the. Okay, now it's a better one. So I select this face inside, and I select the inside face, and then when I define the engineering, now you see that it shows as a concentric. So one way that you can change the type of the construction constraint is that from this section, from the top, you can select the different options here. So cylindrical, put the two circle at the same center, and the planar, put the two plane and contact together. Or if you define the, for example, the gear, they put the two, if you have a two gear, they put it in contact with each other and they move in relation to together. So this is the mechanical, these are the mechanical type of the connection. Or you can right click on the icon here, and then you can have a replace. So I right click on the type, and I can replace or delete the constraint that I have. So we can define the different type of the constraint here. So right now I want to make them concentric, so I click OK. So now it put my the center of this hole with the bar as the same center. The next thing is that I click on this two face, and I select the back of this, keep the control down, click this face, and in this time I put these two in contact. So now, because I already have one relation between this part and the next part, it asks me that I want to create a new constraint, or I want to add this constraint to my existing constraint. So I will add this to the existing constraint because I want these two I want to put them together. So this connection and concentric is part of the same same command that I want to do. So I click OK. So now you can see here I have the previous connection or previous mate that I created, and then I have the new mate that I put here. So now the back of the plate and this bar is in contact together. Okay. Okay, so now I define the relation between some of these parts. Okay, now let's say that I want to put the distance between this plate and the back of this plate as some certain distance, like the 15 millimeter or 20 millimeter. To do that, I click on the new constraint and I select this plane. Then I keep the control down. First, I need to rotate the parts, so let me rotate select the back of this plane, then I select this plane, and then I select the constraint, and now you can see that it contacted the plane to that face, but I want to define the distance, so I right click on the type of the contact and I replace that and I put the offset. So when I put the offset, you see that it gives me the automatically give me the options to define the value. So I put this value as for example 40 millimeter. So if I select only put the 40 millimeter, it put the part in the distance of the 40 millimeter here. But the problem is that now, because I selected as a new constraint, the distance, the connection between this plate and the rod is not working, because this is a new relation. So one thing that I want to do is that I want to add to the relation between the back of the rod and the back of the plate at the same constraint that I put for the relation between these two. So I click on this one and I click on the new constraint, and here I select the select the insert and I put the offset. Now it asks me to select the plane that I want to put as an offset here. So I need to select go to the tools. I need to rotate the picture, so I go to the view and I select the pan. So now I have the select this face. Now I need to move it back again to this one, and for the next face it doesn't let me select the original face, so I need to let me put the new, select this face. So first I need to define the type of this, so I select the offset, I select this plane, then I move the parts, then I select this plane and put the value 40. Okay, now you can see that it moved my parts. No clash, good one. So now the distance between the rod, the back of the rod, and the back of my part is 40 millimeter. Now if I want to put a bracket for the movement of this part, let's say that I can say that I want to say that this bar move between the 40 to 10 millimeter. So this bar move between inside the my base in the bracket of the 15 millimeter to 40 millimeter. So I can go and edit the my offset here, and this time if I double click on the lower value, so here in the lower value I put the 15 millimeter, and in the upper value I put the 45 for example, and I will say that sit down in the 40 millimeter. So now in the at the first view it sit down at the 40 millimeter, but I have the options to move the part between the 40 and 15 and 45 millimeters. So the next thing is that I want to do is to make these faces parallel to this edge for my base. So if I go and look at the this view, we can see that this plate is not parallel to the face of my edge of my base plate. So I want to make sure that I have them these three plane parallel to each other. To do that, I go to the assembly, and then I select the assembly and the mate, and then I right click on the type and I select insert and I put the parallel. Then I select the faces that I want to make the parallel. So these two are the faces that I want to make them parallel, and the next step is that it asks me for do I want to make them as a new inside the new mate, or make them as part of the previous mate. I just make them as a part of the previous mate. So now I have the make this face parallel to the plate, and the last thing is that I want to make these two plate to be parallel to. So I click on the new constraint, I select the or new mate, and I select the parallel. I select this face, then I select the edge of my plate, and I say that I want to be part of my previous, and I select OK. Now everything, all of these three faces are parallel to each other, and I go back and see on the view, you can see that my faces are the edges are in parallel to each other. So this is the one way to put the connection and also the relation between the your parts in the assembly. Okay, to go over more detail about the assembly and do some advanced feature, I run the one video that show you some more options to do the work with your assembly.
Any product we see around us is typically a combination of parts designed to function together in a group or assembly. We can use the Assembly Design app to create, analyze and validate assemblies on the 3DEXPERIENCE platform. In this video we will learn about the main functionalities of the Assembly Design app and consider a shock absorber assembly as an example. The typical process for creating an assembly starts with gathering the data of each part and assessing the fit, form and function of the final product. With this, we can decide how we can connect the parts together, so that they can perform the required functions. We have already created the parts and have them ready. We create sub-assemblies from the parts. The groups of parts that do not have any relative motion between themselves in the kinematics of the assembly generally form a sub-assembly. This is typically the case for small products with few parts. Other considerations are taken into account for larger products. We create the assembly from these sub-assemblies and parts. They are connected together with engineering connections. This is called the bottom-up approach, as we are moving up from the low-level parts to the high-level assembly. We will follow these 9 simple steps to understand the basic process of creating the assembly. We will click the west quadrant of the compass for the 3D modeling apps. If needed, we can activate the 3DEXPERIENCE client role. We will open the Assembly Design app, and a new physical product will be created automatically. We will specify the title damper rod sub-assembly for the new physical product. In a physical product, it is possible to insert multiple existing 3D parts, drawings or other products, or create new ones. We will right-click the appropriate node. After clicking Insert, click Existing 3D Part from the drop-down menu. We can search for the parts in the search bar and select the item from the search results. We can select the parts open in the session by simply opening the appropriate tab and clicking the item in the tree. The inserted components are unconstrained or free to move. We can use the robot to manipulate them. They can move linearly along the 3 directions or rotate around the 3 directions. These are called the 6 degrees of freedom. We can use the degree of freedom display command to view the degrees of freedom available for each component. We can see the 6 degrees of freedom displayed here. To restrict the degrees of freedom, we create engineering connections using constraints between components and model kinematic relations. Here is a list of available engineering connections. In this example, we will first create a spherical engineering connection. We will click the template icon. This creates a default template of constraints required to imply a spherical joint. This template suggests the need to specify 2 points which are the centers of the 2 spheres. We will make them coincident. We can click the spherical surfaces to specify their centers. The current interference status is contact, and that there is no clash detected. By clicking Yes, we ensure that the contact is always checked and any change will be reported. To model any kinematic relation, we must fix one part, so that the other part can follow the relation with respect to the fixed part. We will temporarily fix the piston damper rod 3D part and view the degrees of freedom. If we had not fixed one part, the sub-assembly would be freely floating in space. We can see that the base part is fixed and the damper ring is partially constrained. The damper ring has 3 rotational degrees of freedom and no linear degrees of freedom. Now let us manipulate the damper ring 3D part. Manipulation is used to manually move the parts for better visual observation, selection of overlapped features, or checking the effect of constraints. We will select the checkbox with respect to constraints. This will only allow manipulation following the constraints of engineering connections we have applied. We can see that linear motion is restricted and rotational motion is allowed. We have assembled the first 2 parts. Similarly, we can insert more parts and assemble them. This is the final damper rod sub-assembly. We will now create the shock absorber assembly in a new physical product and add the damper rod sub-assembly and some existing sub-assemblies. we have inserted sub-assemblies the same way we inserted the previous parts. For this engineering connection we have not specified the type, and we will let 3DEXPERIENCE compute the type of connection applicable from the inputs we provide. The two axes will be coincident, whereas the two faces will be offset. In this example, we use the controlled mode to specify the value of this offset such that it can vary between an upper limit and a lower limit. Engineering connections with controlled mode can be used to control and animate a mechanism in kinematics using a slider. We can specify the preferred positioning of one of the components as above or below the other. The direction of orientation of components can also be specified as same or opposite. As we assemble all the components, we can observe the tree and the structure of the assembly. The top level is the assembly node, which contains all the involved sub-assemblies, parts, engineering connections and materials. The sub-assembly node contains the parts and engineering connections from that sub-assembly. Selecting the tree items highlights the related components from the geometry area. The product structure can be changed by reordering the items in the tree. We have completed the assembly and now we will create the interference simulation. We will select the checkboxes under the Specifications tab as required for analyzing clash, clearance or contact between all parts in general and related to engineering connections. Compute quantifier will measure the amount of interference. We can see that one clash has been detected. We can view the details like parts that are involved in the clash, and a quantifier value calculated based on the amount of clash. The specific clash sites are highlighted in red and the parts involved in the clash are colored. We can use the context transparency slider if we want to view the other parts for reference. We can also use the sectioning command to visualize the interference using section views. We can select options like sectioning plane, using the context toolbar and also drag the plane to move it. We can see that the damper ring part has a hole diameter smaller than the axle diameter intended to create a tight interference fit. In this manner, we can analyze and validate the assembly we have created, and save time during actual manufacturing and assembly of physical products. In this video, we will explore the advanced functionalities of the Assembly Design app. These functionalities help the user simplify the process of designing, managing, and updating complex assemblies. Here are a few topics we will cover in this video while we design the shock absorber assembly. In some scenarios, you will be required to create features in assembled products. These features may impact multiple parts in the assembly, for example, a hole through multiple parts. This is called an assembly hole. Here is a list of such assembly features. In this example, we are creating an assembly hole.
A new 3D shape will be created at the root level of the assembly. Name it assembly hole. Click the surface where the hole should be placed. This warning notifies us that the element we are selecting does not belong to the body we are working on. Hence, a link will be created between these two. Click OK. Select the extension of the hole to reach out to plane. Specify the diameter as 20. The limit is the plane up to which the hole should extend. We will select the limiting plane from the part. We will specify the direction as required. We will preview the hole to check if it is oriented correctly.
we will click OK to generate the hole. As this hole is an assembly feature, and it is supposed to pass through multiple parts, we will need to specify the impacting parts. We will click Preset My Clash to automatically list the parts that clash with the hole shape. We can click on the individual parts from the list to highlight them in the geometry area and verify if we want the hole to impact them. We will click Update, and the assembly hole is generated through the selected parts. As the assembly features are created at the root level of the assembly, they can be seen here in the tree. The external references node includes the elements that have been used as references for creating the assembly feature, but are not a part of it. If needed, we can edit the assembly features using double-click on the assembly feature in the tree. It is also possible to edit the whole definition in the list of impacted parts. Sometimes we need to duplicate some parts within the assembly. Depending on the location and the number of these parts, we can use two commands to duplicate parts. In this example, we will use assembly symmetry to duplicate parts in the assembly. We will select the part which is to be duplicated. Next, we will select the plane about which the parts will be positioned symmetrically. It is a better practice to select the items from the tree than the geometry area. This ensures that the correct element is selected. We can see a preview of the positioning of the parts. The assembly symmetry definition panel is used to specify the parameters for the results we want to achieve. Similarly, the other parts can be duplicated. We can see that the duplicated parts have a suffix, as we had specified. Generally, interfacing parts are designed using references of elements from one another. This creates a dependency of dimensions, which makes it easier to modify the parts when needed. This is called designing in context. We will design the central axle by taking external references from other parts. We will insert a new 3D part into the sub-assembly. We will name the part as central axle. We will double-click the 3D Shape node to open the part design app and create the part. We will create a position sketch on the vertical symmetry plane. We want to create the axle by taking reference from the existing hole. We will project the edge of the existing hole onto the sketching plane and use the sketch as the cross-section for the axle. We will create a pad and use the mirrored extend option as we have sketched on the central plane. We have refined the axle part and added lock rings at both ends. Sometimes we have copies of same parts to be assembled at multiple locations. In this case, we can easily reuse the parts within the assembly. This also saves memory and improves the performance of the computer when working with large, complex assemblies. For a better understanding, here we can see a graphical representation detailing this. Imagine this table with 4 legs. There are 4 instances of the leg. They are all linked to just one reference of the leg. Any change in that one reference will reflect in all the instances. Now that we have an idea about what are references and instances, let us look at some of the important terms. As we have designed the central axle by taking external references, the links can be seen here.
Link is a dependency created and used to transmit geometric, parametric, and positional information between components. Relation is a set of links that are specified between components within a product. Context indicates the path of the instances under which contextual links have been created. Import indicates the relation with the original contextual reference. We can view the links in the graphical format also. Here we can see the legend and learn to identify various links. We can check whether the weight information is available for the parts in the assembly. We will use the weight definition command for this. We can see that the weights of the green components have been computed using the applied material, while the weights of the red components are missing. These are the components we had duplicated. The weights of parts can be declared manually or computed automatically using the material parameters like density, if the materials are applied. We can use the weight distribution command to analyze how weight is distributed over the assembly. The heaviest parts are colored darker. We can click on the links to view more details about the part like center of gravity, volume, etc. In this way, we can use the advanced functionalities of the Assembly Design app to simplify the process of designing, managing, and updating complex assemblies.